Hello everyone, welcome back to one more session of this IoT course. Last session I have demonstrated smart parking using Tinkercad. Today I will show you some of the implementations of simple projects using Tinkercad. Agenda of this session: temperature control of a room using temperature sensor, automatic street lighting system using LDR sensor. First project is temperature control of our room using temperature sensor. Problem statement: temperature control is extremely important in modern industries, especially food industries, laboratory, pharmaceutical industries. Food safety law states that all food products have to be kept at designated temperature. If they are going to be safe to eat, having them too cold renders them inedible and too warm, and it could encourage bacteria growth. So it is essential to have a temperature control to protect the health of the consumers. It is very important to keep track of the temperature not only in offices and labs but also in our home. In this module, we look forward to implement a cheap and effective solution to this problem using a microcontroller, that is Arduino, and temperature sensor and LED. So now I will explain the circuit diagram. Guys, you can see this is the temperature sensor which has 3 pins. One is connected to ground, one is connected to VCC, another one, that is the data pin, is connected to A0 pin of the Arduino Uno board, by which Arduino board will get to know about the temperature value, or you can say Arduino can take the input from the sensor, that is the temperature value, by using A0 pin. So now guys, you can see there are 5 LEDs. The main purpose of each LED is to indicate the range of the temperature. Guys, you can see this LED from right side, that is the green one, is connected to output pin of, or you can say digital pin of Arduino, that is pin number 2, and next one is the 3, then 4, then 5, then 6, and the other pin, that is the cathode pin of each of the LED, is connected to the common ground via a resistance. Okay, so this is the circuit diagram. Now I will explain the code. As you can see, this is the sensor pin A0, already I told you, that helps to take the temperature value from the sensor, and the baseline temperature is minus 40. You can take any value whatever you want. For easy understanding, I have used minus 40. Guys, you can see this is the setup function. Also I have written one serial.begin 9600, that is the baud rate. Already I told you, for serial communication with the serial monitor. Okay, so now I have initialized all the output pins, that is the LED output pins, that is basically the anode pins. So guys, you can see from 2 to 6, already I told you there are 5 output pins for LED. So guys, you can see pin number, I have used one loop starting from 2 and end with 6. Okay, so that is why there are 5 pins. As you can see, these are the output pins, and we have initialized by value 0 or you can say low. This is the loop function. This is the analog read function. Bring the value from the sensor, that is temperature value, and store it to sensor val variable. You can print the value also if you want. Now I have converted the sensor value into the voltage by using some standard formula. You can also print the value of voltage. Now voltage is converted into the temperature. Okay, you can print the temperature also. So now I have used one if statement. If temperature value is less than baseline temperature, then digital write pin number 2 is high. Okay, the first LED will start glowing. Okay, we are setting different LEDs for different temperature ranges. Already I told you. Else, if temperature greater than equals to baseline temperature plus 1 and then temperature less than baseline temperature plus 20, then LED 3 will glow, because guys you can see digital write 3 high for this condition. Then for next condition, digital write pin number 4 high, so that means the third LED will glow. Third LED will glow. For this condition, guys, you can see, for this condition, the fourth LED will glow because digital write 5 high for this condition. And lastly, you have digital write 6 high, that means the fifth LED will glow for this particular temperature. That means we are setting different LEDs for different temperature ranges. Now I'll open Tinkercad, that is Tinkercad.com. First, I will demonstrate temperature control project. Nice. Guys, you can see the dashboard of Tinkercad. Already I have created all these projects. So let's start with temperature control of a room. I've already created this circuit, that's why I'm not making it once more. Click on Tinker this. Just wait a minute. So first I'll open the code, but I've already explained this one. As you can see, same thing. As you can see, the code, same thing. Okay, so I have used A0 as sensor pin, that is analog pin, already I told you, and baseline temperature value -40, and then I have used one serial.begin function to set the baud rate, that is 9600 in setup function, and I used one pin mode function for setting up sensor pin as input pin, and then I used one loop which is initialized to 2 and go up to 6 to initialize the LED pin as output pin, and also initialize each of the output pin low. So the LED output pin is the LED anode pin. Next we have the loop function, where we've used one analog read function which is reading the value from the sensor, and you can print the value also, guys. You can see I have used one serial.print function to print the value. Then I have converted into the voltage. Also I have printed the value of voltage. Then I have converted voltage to the temperature, and then I have used different conditions for glowing the LED. You can say I have used different conditions to indicate the range of temperatures, okay, and accordingly LED will glow, as you can see. So first one is the pin number 2 is high, that means the first LED, then pin number 3 will be high, and pin number 4, then pin number 5, then pin number 6. Okay guys, so now I'll close this one and start simulation. Guys, you can see started, simulation started, yes. Okay, so now guys, you can see this one is high, because this one. So now if I go to this, guys, you can see the first one is high, that means it is now minus 40, okay, temperature. So now when you increase the value, as you can see, one after another LED will glowing, okay, depending on the temperature. I'll show once more. From right side, green LED is glowing, and when I increase this value, just a minute, increase this value, one after another LED will glow, okay guys. And you can also open the serial monitor to check the value. This is the serial monitor, as you can see over here. This is the sensor value and the voltage value, right? You can see this one. As you can see the temperature value from here, from serial monitor, as you can see that. This is all about this project. Stop simulation. Now I'll come to another project that is called automatic street lighting using LDR sensor. Problem statement. Street lights consume lot of power in the cities. Many times it is noticed that even after sunrise the street lights are on. A great deal of energy is wasted in this way. Here in this module, we use a microcontroller and a LDR, that is light detecting resistor sensor, to tackle the problem. Now I'll explain the circuit diagram. This is Arduino Uno board, this is buzzer, this is LED, and this is LDR sensor. So LDR sensor is connected to Arduino via A0 pin, that is analog pin, by which Arduino will get the value from LDR sensor through A0 pin. LED is connected to pin number 7, that is a digital pin of Arduino board. That is anode pin of LED is connected to pin number 7 of Arduino board, that is a digital pin, and another pin, that is a cathode pin, is connected to ground, common ground. And this is a buzzer also, guys, you can see it is shorted with LED, that means when LED will glow, immediately buzzer will start ringing. Okay, this is all about the circuit. Now we'll come to the code. So guys, you can see sensor pin is A0, already I told you. Select the input pin for LDR. So guys, you can see this is the LED pin, that is a anode of the LED is connected to digital pin number 7. Then this is the sensor pin value. This is a variable where we store the sensor value. Variable to store the value coming from the sensor. This is the setup function. I have used serial.begin 9600. 960. This is the baud rate for serial communication. And then I have used one pin mode function where I set up one lamp pin, that is your LED anode pin, which is the output pin. Then we have a loop function. Here I have used analog read functions, which is taking value from sensor pin, that is A0, read the value from the sensor and store it to sensor value variable. Then you can print the sensor value if you want. Guys, you can see the code. If sensor value is less than 1005, I have used this threshold value for this sensor. Then LED will glow, or you can say street light will be on. Else if sensor value greater than 1017, then LED will be off, or you can say street light will be off because of sunrise. So I have used this 1005 and 1017 depending on the sensor specification or sensor value. Okay, so that's it for the code. Now I'll open Tinkercad, that is tinkercad.com. So guys, this is automatic street lighting project or system, you can say. I have already created this circuit, that's why I am not making it once more. So click on Tinker this to open it. Please wait. So guys, this is the circuit already I have explained. This is LDR sensor, this is buzzer, this is LED, and I have used resistance also. This is Arduino Uno board. So guys, this is the code. Okay, so already discussed this thing. Sensor pin is equals to A0 pin. This is the analog pin. Arduino will take input from the sensor, that is the sensor value, and I've used one LED output pin, that is the anode pin of LED, the lamp pin, which is basically initial is to 7, digital pin number 7 of Arduino board, and then I have used one setup function. So where I have initialized the serial.begin 9600, that is the serial communication speed, you can say. Then we have one pin mode function to set sensor pin as input pin, and then another pin mode function to set up the lamp pin as output pin. So in loop function, I will use one analog read function that will read the value from the sensor, and also I have printed this value by using serial.print function, and then I will use one delay for 100 millisecond, and if sensor value less than 1005, then street light will be on, or you can say LED will be on, and when sensor value greater than 1017, then LED will be off, or you can say street light will be off, that means sunrise. So now I'll execute this code, start simulation. Okay guys, as you can see, the buzzer is ringing and everything is on. So now click on that. I will increase the differential value. As you can see, when it is like this, that means it is off, that means sunrise. As you can see the symbol of sunrise. So when we'll shift this to left, as you can see, it will be on, that is the street light will be on and buzzer also start ringing. As you can see, on sunrise, that means LED off. So now you can also check in the serial monitor the value. As you can see, the value is 1018. That means greater than 1017. So that means LED off. But previously it was less than of that, guys. Okay. So I'll show you one more thing. This one is LED. This is the value. I'll just shift this thing to this side. That is where LED is on. Otherwise the button is not ringing. As the button is ringing, go to code and check the serial monitor value. As you can see, the serial monitor value is less than 1005. So that is the project. So now I will click on code once more and stop simulation. So by this way we can design this kind of automatic street lighting. Okay, this is very useful nowadays to save the energy. That's it.
That's it for today. Thank you very much.